So let us take some questions on this topic of loci in complex plane. So the first question is the complex numbers z satisfying mod of z minus 5i by z plus 5i is equal to 1 lie on what? Again, this looks like a standard loci which looks like mod of z minus z1 by z minus z2 is equal to 1, where z1 is 5i and z2 is minus 5i. So we have already seen that mod of z minus z1 by z minus z2 is equal to 1 represents the perpendicular bisector of the line segment joining z1 z2, right? So here if you plot this on a organ plane, the first complex number is 5i, that is, it lies on the positive imaginary axis. The second complex number z2 is minus 5i, so it lies on the negative imaginary axis. Now mod of z minus 5i is equal to mod of z plus 5i, that is, z is equidistant from plus 5i and minus 5i. This represents the perpendicular bisector of the line segment joining plus 5i and minus 5i. So obviously the perpendicular bisector of the line segment joining plus 5i and minus 5i is the x-axis or real axis. Hence the locus is a straight line which is the x-axis or the real axis. So in this question, you're given that mod of z minus I plus mod of z plus I is equal to k represents an ellipse. If that is so, what should be the interval in which k has to lie? So we have already seen this in our theory. Mod of z minus z1 plus mod of z minus z2 is equal to k represents an ellipse if k is greater than mod of z1 minus z2. So in this particular case, z1 is nothing but I, z2 is nothing but minus I. So my value of k has to be more than the distance between z1 and z2. So if you take the organ plane, z1 is I and z2 is minus I. And obviously the distance between them is equal to 2 units, right? So if this equation has to represent an ellipse, my k has to be greater than the distance between z1 and z2, which is 2. Hence, k has to belong to the interval 2 to infinity. If z is more than 2, then if k is any number greater than 2, this represents an ellipse. So in this question, you're given that mod of z plus 1 is equal to root 2 times mod of z minus 1. That case, what is the nature of locus? In a very straightforward question, mod of z plus 1 by z minus 1 is equal to root 2, right? If you bring this onto the denominator. So now it is of the form mod of z minus z1 by z minus z2 is equal to some number which is other than 1. So for any number other than 1 here, the locus is a circle. So in this question, you're given that argument of z plus 1 by z minus 1 is in between pi by 3 and 2 pi by 3. If that is so, plot the region that corresponds to the complex number z satisfying this inequation. That's the question. You're asked to plot the locus of z satisfying this condition. Now what is the meaning of this condition? Argument of z plus 1 by z minus 1. Z plus 1 is nothing but z minus of minus 1 by z minus 1. Has to be in between pi by 3 and 2 pi by 3. So the meaning of this is nothing but the angle between the vector z minus 1, that is the vector joining 1 to z and minus 1 to z. The angle going from initial vector to final vector has to be in between pi by 3 and 2 pi by 3. So we have seen that if the angles are somewhere in between other than pi by 2 and minus pi by 2, you get sectors of circles. Now let us see whether this z lies above this plane or below this plane. So if you take a point Z, if you take a point Z on the region above x-axis. Now let us see whether these conditions are valid or not. So the vector joining 1 to Z, that is this vector. So this will be the initial vector, right? The denominator represents the initial vector. And the final vector is the vector joining -1 to Z. This is the final vector. Now if Z lies above x-axis, as you can very clearly see, the final vector lies below the initial vector. Now the angle that is made between the initial vector and final vector is, as you can see, clockwise. That means this angle will be a negative angle. So you won't get positive angles correspond to this argument in the region above x-axis. So now let us go to the region below x-axis. So now let us take a point Z somewhere like this. So what is the initial vector? The vector joining 1 and Z. So this is the initial vector. The final vector is the vector joining -1 and Z. This vector. So this is the initial vector. This is the final vector. So the angle that is going from initial to final is exactly, as you can see, it is in counterclockwise direction. So you get a positive angle. So now let us try to plot the region correspond to Z exactly equal to pi by 3. If argument of Z plus 1 by Z minus 1 is exactly equal to pi by 3, so it represents a sector of a circle of a specific size such that this angle is equal to 60 degrees. So if this angle is 60, then the angle at the center is equal to 120. You can find the center very easily. So corresponding to argument of Z plus 1 by Z minus 1 is equal to pi by 3, you get this sector. And corresponding to argument of Z plus 1 by Z minus 1 is equal to 2 pi by 3, you get a major arc. So if you take a Z here, so as you can see, the angle between the initial vector and final vector is an obtuse angle. So if you take a minor segment, so you get an obtuse angle. If you get a major segment, you get an acute angle. So at all these points, the argument is equal to 2 pi by 3. At all these points, the argument is equal to pi by 3. So now my argument has to be in between these two. So my region corresponding to my locus is the region in between these two circles. The region in between these two circles is the region corresponding to the locus. Thank you.